Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today we're going to continue our topic thermochemistry under subtopic heat of combustion. So we already learned three heat previously, which is in previous lesson, which is heat of precipitation, heat of displacement, and also heat of neutralization. Okay. So basically, in our daily life, we always conduct the combustion process, the combustion reaction, whereby at the kitchen, we normally use our gas stove for cooking. Okay, but why when you try to cook like the meat, okay, using gas stove, it is much more easier and much more faster rather than we use the charcoal to heat up or to cook our meat. Okay, it will take longer time if we compare when using the gas stove. Okay, so kalau kita pakai charcoal and then we burn the charcoal, we put our meat, so masa yang diambil will be much more longer compared to we cook the meat using the gas stove. Why? So I think everyone know, because each of the substance, which is the gas stove and also the charcoal, produce different amount of heat during the combustion. So dia orang akan bebaskan amount of heat yang berbeza, yang menyebabkan proses memasak meat will be different. Okay, so to more understand about this, look at what is explained in the textbook. So the example given here is CH4 plus O2. So we got CO2 plus 2H2O. The delta H is negative 394 kJ per mole. What does it mean? This is the thermochemical equation. So thermochemical equation is the chemical equation including the value of the delta H. So if you just write the normal equation, that is known as chemical equation. But when you are asked to write the thermochemical equation, meaning that the chemical equation plus with the value of the delta H. So what does it mean by this thermochemical equation? It means when 1 mole of methane, this is the methane, is completely burned in oxygen, heat release is 394 kilojoule. So when we write in the form of statement, okay, we write the heat release, no need to put the negative sign, just heat release is 394 kilojoule. So the heat release is known as heat of combustion. Why? Because it is represent the heat release for 1 mole. Okay, heat release for 1 mole, so that heat release will known as heat of combustion. So now let's look more to be more understand about this. Let's look at for the definition of heat of combustion. What is heat of combustion? Heat of combustion is heat release, meaning that every time we conduct the combustion, will be the exothermic reaction. Why? Because we are talking about heat release. So this is exothermic reaction. And the delta H for sure will always negative sign. Okay, so heat of combustion is heat release when 1 mole of a substance is completely burned in excess oxygen. So what is the idea from the definition here? So we can say it is always complete combustion. When the complete combustion, so for sure the product will always same for any combustion that we conduct. Okay, for this subtopic, so we only choose a complete combustion. So complete combustion, the product supposed to be the carbon dioxide and water. Okay, tak kisah what substance that you choose, it always produce carbon dioxide and water. And then when we are talking about the combustion, it must be a substance. Okay, a substance. The substance can be either the alcohol like the methanol, ethanol, propanol, and so on. So you already learned about this in chapter carbon compound. Or the substance can be any alkane or any alkene or any alkyne. But normally is either alcohol or alkane or alkene. Okay, and when we are talking about combustion, meaning that we need the oxygen. So what can we say here? If we have the heat of combustion, so the chemical equation is confirmed, we have any substance. Any substance is depends on what the substance that we have. It can be the alcohol, the alkene, the alkane. And then you must put the oxygen in the equation because it is burned in excess oxygen. And the product is absolutely or confirmed the only product is carbon dioxide and water only. So there is no else. Okay, tak ada benda lain. When we are talking about heat of combustion, we just need to be more careful about, just more cautious about what is the substance. The rest is same. React with the oxygen, produce carbon dioxide and water. So the example here, I have C3 with the propanol react with oxygen. So the substance is propanol react with the oxygen. So my product is carbon dioxide and water. Same goes if I have the ethene react with the oxygen in excess oxygen. So I also get carbon dioxide and water. So sama je. Yang berbeza adalah the substance. Okay. So look at the example. The thermochemical equation for the complete combustion of ethanol is shown below. Okay. So we have ethanol react with 3 mole of oxygen, produce 2 mole of carbon dioxide and 3 mole of water. And the delta H is negative 1376 kilojoule per mole. What does it mean? It means that when 1 mole of ethanol, why I'm talking about ethanol? Because look at to the definition. The definition said that the heat of combustion is heat release when 1 mole of the substance is burned. So who is burned here? The ethanol is burned. So mole yang kita akan focus is the mole for the ethanol. So what does it mean by this equation? This is when 1 mole of the ethanol burn in excess oxygen, 1376 kilojoule of heat is released. Okay, this is meant by this thermochemical equation. Calculate the mass of ethanol needed to burn completely. The mass needed to burn completely in excess oxygen in order to raise the temperature of 200 cm3 of water by 50 degrees Celsius. So from this statement, we can say the temperature increase. Okay, temperature increase by 50. So straight away we can say the theta is 50. Dia dah bagi dah. Dia tak bagi initial or highest temperature. Straight away dia bagi the value of the theta because it's mentioned here raise the temperature by 50. So 50 is the theta. Okay. Assume that no heat is lost to the surrounding and specific capacity of solution is 4.2 and the density is 1 and the molar mass of ethanol is 46. So the information here is about the delta H and then is asking you about the mass of the ethanol. So from here, what we need to know is, okay, delta H. The formula for the delta H is mc theta over mole. Okay, and what is m for the heat of combustion? The m. Normally, M we mention as the mass of solution. Okay, but this time you need to know the mass of the solution for heat of combustion is already fixed, which is the mass of the water. It's never changed. Okay, mass of the water. Why? Because during the combustion, to get the heat of combustion, we always heat water. Heat up the water. Kita panaskan air. Okay. We heat the water and then we're going to check the temperature change before heating of the water and then after the water is boiled. Okay, so kita panaskan air using the substance. So the substance we're going to burn, okay, and then release heat. Heat release is used to raise up the temperature of water. So mass of solution tak pernah berubah for the heat of combustion only. It always the mass of the water. For the other 3 heat of reaction, dia akan sentiasa berubah depends on who is the reactant that we use. Okay. And C is always specific heat capacity of water and theta is the temperature change. Okay, what is the mole? The mole here is the mole of the substance. It depends on what substance that we use. And normally, for the 3 heat of reaction, when we want to calculate the number of mole, we use MV of 1000. Special for heat of combustion, the number of mole for the substance, okay, we don't use MV of 1000, we use mass over molar mass, because the data is in the form of mass. The question is, even though the substance is the reactant, okay, and normally when we are calculate the mass of the solution, kita akan ambil the reactant, the solution, the reactant yang dalam bentuk aqueous solution. But this time, why the mass of the solution kita ambil water? Is it the water in the product? The answer is no, not this one. Okay, this is the water that we use to heat. We heat the water, kita panaskan air menggunakan our ethanol. So air itu adalah kita punya mass of the solution, and then that water kita tak tulis dalam kita punya chemical equation. Tapi kenapa we don't use the mass of the solution from the ethanol? Kenapa we don't use the ethanol as the mass of the solution? Because the ethanol is not the solution. Ethanol is the liquid, okay, liquid form, and then the data from the ethanol, from the alcohol, from the substance will be given in the form of mass. Okay, soon I will show to you how the experiment will be conducted. Okay, so from the idea that MC theta of a mole, and then we have the data about the theta and the mass. So now we can calculate the heat release. Okay, heat release is Q equal to MC theta. So just now I already told you that M is mass of the water. So our water is 200 cm cube. So it will be 200 gram. And then C is 4.2, and theta is temperature change is 50. So use your calculator. So you will get heat release is 42,000 joule, or you can convert into kilojoule, which is 42 kilojoule. Okay, don't forget the unit. Okay, so this is the Q. The question asking you about the mass of the ethanol. Okay, this is Q, MC theta. So how can we get the mass of the ethanol? Okay, so from the thermochemical equation, we'll know that 1370 heat of kilojoule of heat is released when 1 mole of ethanol is burned. Okay, so that is the value. Therefore, 42 kilojoule is released from 42 times 1 over 1376 of ethanol, which is 0.03 mole of ethanol. So to make you more understand about this, I try to make it simple. Okay, so we have the data. The delta H is 1376 kilojoule per mole. Okay, and just now we already calculate our delta Q, MC theta. Our Q is 42 kilojoule. Okay, so put in the formula 1376 equal to 42 over mole. So we can find the number of mole by dividing 42 over 1376. So the number of mole is 0.03 mole for the ethanol. Okay, so this is the number of mole of ethanol. The question asking you about the mass of the ethanol. Okay, how to find the mass? We have the number of mole. Okay, so to find the mass, we're going to use the formula mole equal to mass over molar mass. So the mass is 0.03 multiply with the molar mass 46 is already given to you, or kalau tak bagi, you boleh kira pakai this method, molar mass punya method. So use your calculator. Your final answer is 1.38 gram. What does it mean? Meaning that 1.38 gram of ethanol is burned to heat 200 cm cube of water, so that the temperature of the water increase by 50. So 200 cm3 air itu dipanaskan menggunakan 1.38 gram ethanol supaya suhu air itu meningkat sebanyak 50. Let's say the initial temperature is 27, so dia naik sampai 57. Banyak mana ethanol yang kita pakai? 1.38 gram. Okay, so this is the difference between heat of combustion and the other heat of reaction. Yang mana formula mole dia berbeza dan the value of N pun kita akan define sedikit berbeza. Yang lain, the rest is follow the same. Okay, so now I'm going to show you how this experiment will be conducted in the lab. Okay, so it is quite different compared to the other three heat of reaction, whereby for the other three heat of reaction, heat of precipitation, heat of displacement, and heat of neutralization, we're going to use the polystyrene cup as our main apparatus. So all the reaction will be conducted in the polystyrene cup, and we're going to mix up the reactant in the same container, in the same polystyrene cup. Maksudnya kita campurkan, let's say, zinc and copper sulfate together, and for the heat of displacement, and then for the heat of precipitation we put together sodium chloride and silver nitrate in the same container, and then for the heat of neutralization we put together the sodium hydroxide and hydrochloric acid in the polystyrene cup, and then we stir, and then we get the highest temperature and we can do the calculation. But for heat of combustion we cannot use the polystyrene cup, it's not suitable. Okay, and we don't mix the reactant like what we did in heat of precipitation, displacement, and neutralization. So look at what is the difference. So in this experiment, we're going to determine the heat of combustion of various alcohol, where we want to prove that as the number of carbon atom per molecule alcohol increase, the heat of combustion will also increase. So we're going to use the methanol, ethanol, propanol, butanol, and also water. Okay, and the apparatus here is the copper can. Copper can is the main apparatus. Okay, why we use the copper can? Okay, so you need to answer this question. Why we use the copper can? Why we don't use the polystyrene cup? For sure, because polystyrene cup is easy to melt. It's not suitable. Okay, but why copper can? Why not beaker? Okay, so we put the water in the copper can. Okay, and then below the copper can we put the type clay triangle. Okay, dia bulat, dia ada in the light is like this. Okay, we don't use the wire gauze, we use the pipe clay triangle, and then we put the alcohol in the spirit lamp, and then we use the wooden block. Okay, so 1, 2, 3, 4, all these 4 steps, okay, is really important. So jangan kita tak boleh ambil mudah lah. We cannot say I want to use the beaker, I don't want to use pipe triangle, I want to use the wire gauze, and then I don't want to use the wooden block because there is no wooden block. Tak boleh we have to follow this instruction. Why? Because the reaction or the combustion is occur between the alcohol and the oxygen at the surrounding. So reaction tu berlaku dekat bawah. Okay, what happen? Let's say you conduct the BBQ, okay, and then you have the charcoal arang, and then the distance between your meat and also your charcoal is very far. Kalau dia jauh, what happen? Berapa lama masa untuk you panaskan ataupun you masak your meat? So I think everyone know it will take longer time. Why? Because the distance is very far, so you dah lost a lot of heat to the surrounding. You dah membazir banyak sangat heat to the surrounding, menyebabkan dia lambat masak. Okay, so that's why we use the wooden block. When we use the wooden block, what happen? The flame, okay, the flame that produced from the combustion of the alcohol will touch the bottom part of the copper can. So dia sentuh bottom part. So we can say very close. Okay. And then when it touch to the bottom part, there will be no penghalang, no shield between the copper can and the flame. That's why we cannot use the wire gauze. Kalau you letak wire gauze akan menjadi penghalang di antara the flame dan juga the copper can. Bila dia menjadi penghalang, so dia akan absorb heat. So kita dah membazir heat kita dekat situ. That's why we cannot use the wire gauze. So we use the pipe clay triangle, so the flame directly touch to the bottom part of the copper can. And why we use the copper can? So as you know, the copper itself is a very good heat conductor. So it's very good heat conductor. So when the heat is passed through the copper can, dia akan terus transfer to the water. Dia tak hold. Kalau you pakai, if you use the beaker itself, dia punya is not very good heat conductor. So when the heat is passed through the beaker itself, dia akan absorb the whole and then baru dia pass to the water. So itu pun akan menyebabkan some of heat is lost to the surrounding, because the container is also considered as the surrounding. So all this form precaution, because we want to make sure heat is not lost to the surrounding. And at the same time, we put the windshield. Why we put the windshield? Because we conduct the experiment dalam keadaan terbuka. So for sure, kadang-kadang akan adanya angin. Okay, macam kalau you conduct the BBQ, sometimes when the wind is blow, so you punya flame akan jadi instead of dia menegak ke arah you punya meat, so dia akan bergerak ke kanan, so menyebabkan the proses itu menjadi lambat, and when we lost a lot of heat to the surrounding. So to make sure we don't have the air disturbance from the surrounding, we put the windshield. So every time the wind blow, we can prevent we can prevent our flame daripada bergerak ke kiri ke kanan. Okay, so all this for precaution is the aim is to make sure heat is not lost to the surrounding. Okay. So what we're going to do, measure 200 cm³ of water. So ini adalah air yang kita akan panaskan, and then pour into the copper can. Place the copper can on the tripod stand, and then don't forget to measure the initial temperature of the water. Okay, the reaction will not occur between the water and the alcohol. Kita bukan reaction water dengan alcohol, tapi kita guna water itu untuk dipanaskan. Okay, air akan dipanaskan, suhu yang akan kita catatlah suhu water. Tapi reaction itu bukan berlaku dalam water. The reaction is occur between the alcohol and the oxygen dekat bawah copper can tu. Okay, so heat release dari situ transfer ke dalam water. This is the difference between heat of combustion dengan heat yang lain. So fill the spirit lamp with the ethanol, okay, and then wait and record the mass of the spirit lamp. So the alcohol kita tak dapatkan dia punya mole pakai MV/1000, because kita tak ada dia punya volume, kita tak ada dia punya molarity, because this is not a solution, dia adalah liquid. So kita dapatkan dia punya mass, and then place the lamp under the copper can, light out the wick, and then adjust the position so that the light of the lamp touch the part under the copper can. This is what I meant just now, supaya there is no heat release to the surrounding. Stir the water in the copper can continuously with the thermometer. Turn off the flame when the water temperature is rise by 30. For this experiment, dia nak rise by 30. In the question just now, dia nak rise by 50. So we decide kita nak rise banyak mana. Kalau kita nak naik 30, initial dia 30, so we're going to stop at 60 degrees Celsius. Kita kena put off the flame. Okay. And record the highest temperature of the water. And record the mass of the lamp immediately after the combustion. Why we have to do immediately? Because the alcohol is highly volatile, meaning that easy to evaporate. So once you put off the flame, jangan tunggu lama sebab dia senang meruap. So you have to immediately letak atas penimbang and then get the mass. Okay, repeat the step using ethanol, propanol, butanol and methanol. Okay, so this is the experiment. So this is explain to you why we use the mass as the mass of the water. Okay, and then kenapa kita pakai formula mole dia mass over molar mass. Okay, from this experiment we can prove one thing, which is the heat of combustion of alcohol. We can prove the relationship between the heat of combustion and the number of carbon atom per molecule alcohol. The data from this experiment, kita boleh buktikan perkaitan di antara bilangan carbon atom per molecule alcohol and the heat of combustion. Okay, so this is the data that we're supposed to get. What does it mean? This is the number of carbon. So we can say it's directly proportional, meaning that as the number of carbon atom per molecule increase, so the heat of combustion will also increase. It's directly proportional. So dia berkadar langsung. So why this happen? Okay. So now I'm going to prove to you. So this is the equation for the different alcohol that we use. We have the first one, we have the methanol, and then we have ethanol, propanol, and butanol. Okay, so what is the difference? Before that, look at what is the similarities. They're going to react with the oxygen, and all of them we're going to use carbon dioxide and water for sure, because kita hanya melibatkan complete combustion. Okay, so apa yang berbeza? The difference is when I have one carbon in methanol, I'm going to produce one carbon dioxide and two water. If I double the number of carbon atom per molecules, so I'm going to produce two carbon dioxide and 3 water. When I increase the number of carbon by 3, so I'm going to produce 3 carbon dioxide and 4 mole of water. When I use 4 mole of 4 carbon atom per molecule alcohol, I'm going to produce 4 carbon dioxide, okay, and then 5 H2O. Okay, what does it mean? Bila carbon dia bertambah satu demi satu, so carbon dioxide is also same, and also water pun sama. So you already learn this part, dia akan berlakunya bond breaking, where bond breaking will absorb heat. Okay, and then at this part, this is the reactant, dia akan berlaku bond forming. Okay, so bond forming, dia akan release heat. So bila makin banyak kita nak form the bond, so makin banyaklah heat yang akan release. Okay, so when the number of carbon atoms and hydrogen atom per molecule alcohol, you need to mention per molecule alcohol, increase. Okay, heat of combustion also increase. Look at to the graph. If I have one carbon, it is 500 kilojoule per mole. If I have two carbons, the data will show to you it 1000 plus. There is like 500 times 2, tapi tak adalah exactly times 2, sebab kita ada banyak lagi faktor lain yang akan mempengaruhi, tapi dia almost is like 1 times 2, tapi not exactly times 2 lah. Okay, kalau 500 tu dia tak ada dah dapat 1000, dia akan dapatlah 1100 macam tu. Okay, tapi itu pun dah is like directly proportional. Okay, so as the number of carbon atoms and hydrogen atom per molecule of alcohol increase, the heat of combustion will be increased. Okay, the reason is when we have more carbon atoms and hydrogen atoms per molecule alcohol, more 1, 2, 3, 4 more carbon and more hydrogen. This is 4, this is 6, this is 8, this is 10. Okay, burn. When more carbon and hydrogen atoms per molecule alcohol burn, so what happened? We're going to produce, yes, more carbon dioxide and water. So more carbon dioxide and water produced, so more bond forming, so more heat release. That is the reason why the heat of combustion also increase. Dan increase dia ni sangat cantik, is increase directly proportional. Okay, so that's all for this subtopic. Oh, before I ending my session, the energy level diagram for the heat of combustion, because heat of combustion is always is confirmed exothermic reaction because it is heat release. So you have to draw it like this type of energy level diagram. Energy, so let's say we choose CH3OH plus 3/2O2. Let's say the delta H is negative 500 kilojoule per mole, and then the product will be carbon dioxide and 2H2O. Okay, they were going to use the same pattern of energy level diagram. Okay, that's all from me for today. Thank you, and Assalamualaikum and salam sejahtera.